Worksheet 60, writing formulas from names. We did a little bit of this with ionic bonds with single atoms and polyatomic ions, and we did a little bit with covalent bonds earlier, so this is kind of a review page. Remember though, you see right there where it says to remember covalent bonds, those are two or more nonmetals, and the words give us the prefixes. So they kind of tell us exactly what we need to write. We don't have to do much figuring out. Ionic bonds have a metal and a nonmetal, or a metal with a polyatomic ion, and they're going to use the oxidation numbers, which is that fancy term for plus or minus charge, what the atom will do with the valence electrons. All right, ready to begin? Well, you see number 1 is already done. Well, notice carbon is the C. Monoxide, we just don't write both O's right there and just say monoxide, 1 oxygen, so C and O. Okay. Now look down at number 6, because that one's already done too. Hydrogen, well, that's your H. Hydroxide is a polyatomic ion, so all I have to do is write it out. And that's it. That's really all we have to do. Last time we took the symbols and wrote the name. This time we're taking the name and writing the symbol. Now that's an ionic bond, so I don't do anything like monohydrogen, which I wouldn't put mono in the first element anyway. So if you're not sure, ask yourself pretty much this. Is the first word a metal or a nonmetal? If it's a metal, you have an ionic bond. If it's a nonmetal, except for NH4, then you're going to have a covalent bond. And if you see anything like tetra, tri, di, mono, that's a covalent bond, and those numbers tell you exactly what to write. All right, so let's go ahead and do number 2 now. Number 2. So number 2, sodium chloride. That's an ionic bond, I know, because sodium is a metal. So all I have to do is the symbol for sodium, Na, second letter's lowercase, and then chlorine. See, that's a single atom, so NaCl. Number 3, we have carbon tetrachloride. Carbon is a non-metal. Chlorine comes from chloride, comes from chlorine, and then tetra in front of it, so we're told what to put there. So carbon, C. Tetra means 4, but we put the symbol first, then the subscript, so C, L, and tetra means 4, so CCl4. And that's really all there is to it. Number 4, magnesium bromide. Well, magnesium is a metal, so Mg. Bromide, if it's an ionic bond, we're not going to worry about anything else except the oxidation numbers. Well, you have to look at something here. Magnesium, here's where I need to put the oxidation numbers, because this is not a one-to-one matchup like sodium chloride is. Magnesium is +2, bromine is -1. So how many -1s will match that +2? That answer is 2. So magnesium, I'll go ahead and write it all out here. Right there. So whatever you put here, you're also going to put here, and this is your final formula, magnesium bromide. Number 5, aluminum iodide. Since it's an ionic bond, aluminum's a metal, iodine is a nonmetal, get the oxidation numbers. Aluminum is +3, iodine is -1. How many 1s make a 3? That answer is 3. So now just write your symbols. Aluminum iodide. And that one is finished. I'll do a few more and then let you finish it up. All right, you notice number 7 says iron 2 fluoride. That's a good thing. Now we don't have to go fishing for the oxidation number because we're already told by the Roman number. Since that says Roman number 2, that iron's oxidation is +2. Fluorine is a halogen. You can look on your charts if you forgot these, but all halogens are -1. How many 1s make a 2? That answer is 2. So iron is Fe. Fluorine, that's where fluoride comes from, is F, and we have 2 of those, so it's FeF2. Number 8, carbon dioxide. Hey, we got the Di to tell us exactly what we need. We don't need oxidation numbers with a covalent bond. Those are both nonmetals. So carbon dioxide. 2 for di, O for oxygen. All right, number 9, carbonate. That's a polyatomic ion. That means we have an ionic bond here. Well, sodium tells me that anyway because it's a metal. Sodium, +1. Carbonate, you look on your chart, you'll notice that is -2. So how many 1s will make 2? That answer is 2 of those. So sodium, 2. Carbonate, look on your chart, you'll see how to write that. Put all polyatomic ions in parentheses. You get sodium carbonate just like that. All right, I'm going to do number 12, iron 3 oxide. Once again, the Roman number is the oxidation, so iron is 3. Oxygen will always be -2. It takes on 2 electrons. Well, now, since I can't just say 2 times anything is 3, remember no fractions, I have 2 ways to go here. I can find the least common multiple of being 6. That means how many 3s make 6? 2 of them do. How many 2s make 6? 3 of them do. So iron is Fe with 2 of them, and oxygen, as you see right there, is O3. Or remember, I can do the 3-2 switcheroo. So I'm going to erase these. And remember, that 3 comes down here, and that 2 comes down here, and no plus or minus. So my answer is still Fe2O3. All right, I'm going to scroll down and do just 1 or 2 more and let you finish it up. Number 15, dinitrogen pentoxide. These are covalent bonds with the prefixes, so the Di and the pent tell us exactly what we need. Nitrogen, Di means 2, pentoxide, oxygen, penta means 5, so dinitrogen pentoxide, N2O5. I'm going to do one more, number 17, and then let you finish it up. Aluminum, chemical symbol for aluminum, Al, but sulfite is one of those polyatomic ions. So we're going to go ahead and get the oxidation numbers. Aluminum has 3 valence electrons, so its oxidation is +3. Sulfite, SO3, has an oxidation number of -2. Hey, you know what? We can do the 3-2 switcheroo, and we're done. Al, sulfite, in parentheses because it's polyatomic, and then remember your subscripts right there. So there is aluminum sulfite. We did the 3-2 switcheroo, or we could have said it this way. Take these off. We need the LCM to be 6. That means +3 twice is +6, and -2 3 times is -6. We still end up with Al2 SO3 3. So I hope that helps. Now you can turn the words into the formulas, and that is all for today. Good night.